In the previous video, we laid out some of the mathematical foundation for partitioning the sum of squares. Now, let's go through the steps and see how it's done. We left off midway through an example in which we were looking at student scores on a history exam. We saw that when our sample consists of multiple groups, we can think of each person's score, their y sub I, as reflecting three different components. The grand mean across all of the people in all of the groups, y double bar, plus the difference between their group mean and the grand mean, y bar minus y double bar, plus the difference between their individual score and their group mean, y sub I minus y bar. All right? Now, using this equation, let's come up with a formula for the sum of squares. To do that, we're going to manipulate both sides of the equation. And remember, we can do that as long as whatever we do on one side, we do on the other side. Specifically, I'm going to make the left-hand side of the equation the defining or conceptual formula for the sum of squares. The sum of y minus y double bar squared and added up, right? Now, notice we're using y double bar this time because we want the sum of squares for everybody in all of the different groups, right? And because both sides are equal, when we make the left-hand side the sum of squares, the right-hand side of the equation will also become an equivalent way of calculating the sum of squares, but it'll be based on these three different pieces that we've created here. Okay? So, to calculate the sum of squares, we first need to subtract the grand mean from both sides of the equation. Notice on the right we now have both a plus and minus grand mean. Those will obviously cancel out, right? So we can just drop them out. And now, looking closely on the left-hand side of the equation, we can see that this gives us deviations from the grand mean, right? So we're on the right track. Now, let's slide this over a bit so we have some more room. And again, so far we've got deviations from the grand mean, but for the sum of squares, we need these squared deviations. So let's square both sides of the equation. And for the sum of squares, it's the sum of the squared deviations. So let's sum up all of those squared deviations around the mean on both sides. We'll now square it. All right? So here we are. Here's a formula for the sum of squares when we have multiple groups, right? But we're not done yet. And this is where it gets pretty cool. Let's expand that right-hand side of the equation. This gets a little messy, so we'll start a new row, okay? Now, we're squaring the y bar minus y double bar plus y sub I minus y bar, right? So let's write that out twice, multiplying it by itself, okay? Now, let's further expand the right-hand side of the equation. To do that, I'm going to add another row here. Now, on the right, this is a squared binomial, something plus something in parentheses squared, right? And if you think back to multiplying binomials, this will be equal to the sum of y bar minus y double bar times y bar minus y double bar, or the sum of y bar minus y double bar squared, plus the sum of y sub I minus y bar times y sub I minus y bar, or the sum of y sub I minus y bar squared, plus the sum of y bar minus y double bar times y sub I minus y bar, all right? But remember, back to squaring binomials, we do this last one twice because we also have the sum of y sub I minus y bar times y bar minus y double bar, which is mathematically the same thing. So we have 2 times y bar minus y double bar times y sub I minus y bar. Whew. Okay. Now, here comes the cool part. Think back to the characteristics of the mean. Remember that the sum of the deviations around the mean always equals 0. The values above the mean and the values below the mean always cancel out in the end. And look closely at this last term. It's the sum of deviations of group means around the grand mean times deviations of individual scores around the group mean. It's the sum of deviations around a mean times deviations around a mean, and the sum of deviations around a mean is 0, so mathematically this entire term ends up equaling 0. Pretty cool, isn't it? So we can just drop that entire term out, and we have our final equation for partitioning the sum of squares. Our sum of squared deviations from the grand mean, right, our sum of squares, is equal to the sum of squared deviations between the group means and the grand mean, plus the sum of squared deviations between individual scores and their respective group mean. Isn't that beautiful? Beautiful. Now, right there, right here, we can see how we've taken this sum of squares and we've split it into 2 pieces that we can add together to get the sum of squares, that total sum of squares that we started with. All right, awesome. And as we're about to see, this is where it starts to get really elegant. All right, now that was a lot of math. So let's step back for a minute and summarize again exactly what we have just ended up with. Starting on the left side of the equation, we have the sum of individual scores, y sub I, minus the grand mean, y double bar. This is the old sum of squares formula. We're just using the grand mean here because we have multiple groups, okay? Now, on the right side of the equation is another way of calculating the exact same sum of squares, but where we've divided it into 2 parts. First, we have the sum of y bar minus y double bar squared. Y bar is the group means and y double bar is the grand mean, so this is just the sum of the squared deviations of group means from the grand mean. This is the sum of squares between our groups, or simply the sum of squares between. That's how you calculate it. Then we have the sum of y sub I minus y bar squared. Remember, y sub I is an individual person score and y bar is their group mean. So this is the sum of the squared deviations for individuals in a group from their group mean. This is the sum of squares within each of the groups, right? Pretty cool. That's the sum of squares within. Now, as we noted, the 2 of these, the sum of squares between plus the sum of squares within, if we add them up, they will equal that overall sum of squares, that we got based on that square deviations of each individual score from the grand mean, right, across everybody. Now, because we're talking about the sums of squares for multiple groups, for clarity, we'll refer to this as the total sum of squares, or the sum of squares total. All right? So the sum of squares between plus the sum of squares within equals the sum of squares total. We have literally divided that old sum of squares into 2 parts. the sum of squares that's related to differences between our groups, and the sum of squares that's related to differences among individuals within the groups. It is beautiful. That's how you do it. So to wrap up, if you want to calculate these sums of squares within, the sum of squares within groups, you take each person's score, subtract the mean for their group, square that value, add it up, I'll add up those squared values across everybody in all the groups, and that gives you your sums of squares within. If you want to calculate the sum of squares between groups, our sum of squares between, you look at each person, take the mean for their group, whichever group they're in, take the mean for their group, subtract the grand mean, square that value, and add up those squared values for everybody in all of the different groups. And this is important. You don't just do it once for each group. You add up the group mean minus the grand mean squared for every person in each of the groups, because that difference, y bar minus y double bar, is part of every person's individual score. All right? Now, with that, let's wrap up this video. This is the tough part. I swear, it's all downhill from here. In our next video, we'll take the sum of squares between and the sum of squares within, and we'll use them to calculate our F statistic. All right? See you then.